Good afternoon or good evening, depending on where you're joining us from. Welcome back to another session as part of the final week of DevToberfest 2024. Today is our MAD Day, our machine learning, AI, and data. And keeping with that topic, we have an excellent session for you today on serving fine-grained models in production. So, with no further ado, I'll turn over to our expert speaker this morning. Over to you, and I'll be back at the end to help out with questions. But otherwise, have a great session.
Great. Thank you, Thomas. I'm happy that you joined our session today about serving fine-tuned models in production. My name is Karim. I am an AI expert in SAP. The topics we are going to cover today are, first of all, a comparison between two approaches, the RAG and the fine-tuning. Then we want to see where it is appropriate to use the fine-tuning approach. And there are also different flavors of doing the fine-tuning, which has implications. And we will take a look at the pros and cons of the different flavors of fine-tuning. And I want to show you a code example that you actually can run on your own laptop because it is using a small model and can be run locally. And you can try out fine-tuning your own model. But then we come to the final part of the presentation, which is about serving a fine-tuned model, so put it to work. And if you are serving customers with fine-tuned models, there are also a lot of aspects to take into account. And we will talk about them in the context of the SAP's Generative AI Hub. So the goal of using LLMs and doing either RAG or fine-tuning is to specialize the large language models on domain-specific tasks. Last year, in the DevToberfest, I was showing the Retrieval Augmented generation approach. Here, the important thing is that the model parameters, the weights of the neural network are not changed. So they stayed as they were previously trained. However, we augment the input of the user with retrieved context. So therefore, the RAG approach relies on explicit knowledge from these retrieved texts. And we have to take care of the quality of this retrieval because there are some parameters like chunking the domain text into the right size or choosing the right embedding model for it. In contrast, the fine-tuning approach does update the model parameters. So it changes the network itself in order to optimize for a specific task. In this way, with fine-tuning, the model will acquire implicit knowledge and therefore reduces also the dependence on external knowledge sources. So in summary, we can say using the RAG approach is in general cheaper and less effort. However, if you don't reach the quality, the response quality of the model that you want to have, then you should try out fine-tuning. However, there is a higher effort and costs involved. Please note that fine-tuning can also be combined with the RAG approach. So on top of a fine-tuning network, still the RAG can be applied to even improve the model responses more. So which use cases are appropriate for applying fine-tuning? First of all, every large language model has a specific input window. and the size of this input window is limited. But this is true both for RAG and fine-tuning. However, the difference is that with RAG, as we are adding and augmenting context, which could be 2 times, 3 times larger than the actual user input, this limitation of the input window size is reached very early. And with fine-tuning, you just have enough. So almost never you will reach this limitation. There is also the term of domain shift, which describes for different tasks or for different domains differences in language, vocabulary, style, and context. So just imagine ChatGPT is trained on general Wikipedia texts and a couple of books, a lot of general text with normal language. But if you want ChatGPT to advise you on legal text or medical, even in the medical domain, then it will maybe not use the right terms and even miss some context. Therefore, the fine-tuning will help the model to understand the terminology and specifically the context in where it is used. Special terms are used. So with fine-tuning, you can improve the generalization. This is true, especially when you have enough data, which is representative of your target domain. This is very important. And RAG may struggle with the generalization because either your knowledge database is incomplete or the retrieved context is not relevant. So also there is another advantage. You can use smaller large language models. So in comparison, there is a 7 billion model which can be served on 1 GPU and is fine-tuned. And the response quality of such a smaller model can be on par with the standard ChatGPT, which includes 40 billion weights and has to be served on 4 GPUs. And this can significantly reduce the costs to run a fine-tuned model and get the same or similar response quality. Now let's take a look at different approaches that are available to fine-tune models. The main approach is the full model fine-tuning. We had similar approaches before the advent of large language models with deep learning networks. There you would retrain the model on new training data and update all parameters of the model. And this is also possible with fine-tuning, with transformer models, with large language models. You could update and train some of the pre-trained weights or even all of them. The advantage is that you can fully adapt to a new domain or task, but this comes with a cost. It is computationally very expensive. And also there's a danger of overfitting and even forgetting the language capabilities that were trained in the general model. So there was a lot of research done how to prevent or even do it differently. And on the bottom of the slide, you can see that there are approaches for doing parameter efficient fine-tuning, which means that you just change a much smaller part of the network rather than the whole network. And the low-rank adaptation, in short LoRA, is a subcategory of the parameter efficient fine-tuning. Here, as you can see in the box, in the graph on the right side, you inject trainable matrices, which are the orange boxes, for each layer of the model. Actually, for each transformer block, you are doing it. So in the blue box, you have the pre-trained weights, and they will not change. So this is the acquired knowledge of the language model. In addition, in order to acquire additional or more specific knowledge on the new domain, only the matrix, the low-rank matrix, or these new weights in orange color, they will be changed. In combination, the output of both parts will shift the model response for the new for the answers in the new domain. And as you can see, the advantages is that it significantly reduces the number of the parameters that have to be trained. It is more memory efficient because it's also smaller. But in complex domains, it may not capture the domain shift. But still, it is proven to be a very good approach. And we have also done experiments and have very good achieved very good results with it. So now I'd like to show you a small code example in a Jupyter notebook where we use the transformers library from Hugging Face, and here we have some high-level objects that encapsulate a lot of the boilerplate code. For example, the auto model for sequence classification. And the task here is to do a sentiment analysis or a classification of movie reviews. Yeah, so the thing that we want to achieve is that we have a label, positive or negative, for a given movie review. And as you can see, that the dataset structure is 1,000 samples for training data and 1,000 samples for the validation data. And the label is only positive or negative sentiment for the review. And as a network, as a base network, we use the Distilbert network. It has around 40 million parameters, in contrast to the 40 billion of ChatGPT. So you can see it's an order of magnitude smaller. And this can be trained, as said before, on your own laptop. And what we do is that we use these nice classes which help us to, with a small amount of code, to load the network. It is also important that you use a network which is able to inject these low-rank matrices. So there are networks files which cannot be changed anymore, but there are also network files, neural network files, which can be extended. And you can find these kind of things here on the Hugging Face page. I included the link into the presentation, and you will be able to access it later. And here the whole topic of parameter efficient tuning is addressed. And in the model section, you can search either for model names or the type of models which support parameter efficient tuning. This means that they can be extended with additional weights. So here we can take a look at the Distilbert network. It includes 6 transformer blocks, which are the major component of large language models and also contribute to the impressive abilities and capabilities, language capabilities of these networks. And for each one of these transformer block, there will be a LoRA matrix, a low rank matrix or LoRA weights injected. I don't want to go into all the details, but what we do first is that we try the untrained model in order to see the difference or the effect of the fine-tuning. So here we have a list of our own custom reviews, very general. I'm not a fan, I don't recommend it, it was better or not worth watching. And as you can see, the model response is not very good. Only two out of 5 is correct. The others, the classification of the other comments is wrong. So now we will going to train this model. And as you can see, first we have to configure our LoRA with some parameters. And especially the task type. This is both dependent on what you want to achieve and which type of model. So here we have a sequence model. So therefore we have to put the task type to a sequence classifier. And as shown before, the training data is only 1,000 samples, and with 10 iterations, 10 epochs on this training data, we already can achieve by loading a trainer class, which includes the network and starts the training. And this can be run in maybe 20 to 30 minutes on your local laptop, even CPU based. It's not even with GPU, it will be faster than that. So I have a Mac M1 chip, and it run easily with 32 gigabytes of memory. And here we can see the effect of the training. So this time, the wrongly classified comments, which is I'm not a fan, I don't recommend the movie, or this one is a pass, or not worth watching, they are correctly classified as negative comments. Also, the link to this notebook is included and will be added to the video. So let's get back to the presentation. And now, after we have fine-tuned such a model, such a large language model, now we want to take a look at the aspects of serving such a model. And here we are especially only talking about the LoRa or the LoRa approach with the LoRa adapters. So just imagine you have two tasks. One is blue and one is red. So because the domains are different, we have trained different adapters, which are colored in blue and red. And the orange and yellow bars you see here is the base model. So you can see that the base model takes the most part of the memory. It is the largest part. And the added weights and the newly trained weights may be smaller in a factor of 100 compared to the large language model. If you have two tasks, then you have to create two separate deployments. And the difference is only the colored weights, which you see down here. So adding more tasks in the future, or having to serve different tasks, raises the costs linearly. So it will be multiplied by the number of your tasks. So this is very costly because the major part is the base model, and it does not change in the tasks, right? It is still the same. So fortunately, it is possible that there is a technology available which allows to have a single deployment, which includes the base model in orange and yellow. In addition, also load the LoRa adapters and switch between these adapters when inferencing the network. This means if a request comes for the blue task, which is domain A, let's say this is medical question, then the network will switch and only use the blue adapters. If we have a legal text, which is a different task, a different domain, we send it to the same deployment, and the network will be able to again only include the red weights and ignore the blue or other weights that are available. And we also have the aspect that in future, when you start such a deployment, there might be coming future tasks, future domain-specific fine-tuned adapters, and you want to add them also to this deployment. In order to have only one deployment, the cost for the major base model, and just switching dynamically between the LoRa adapters. So research in some papers has shown that you can load up to 1,000 adapters, and still the performance of such a single deployment, which switches between these adapters, is still fine and pretty acceptable for the users. Now, what if we are going to provide, so this is, let's say this is an experiment. I have trained on different tasks. I'm just evaluating the different adapters. But now I want to, I have customers. I'm a company like SAP. I have customers, and each customer brings their own adapters. And here, a lot of additional aspects have to be taken into account, which we are going to talk in the next slide. So first of all, SAP provides the AI solutions on an AI platform. Let's take quickly a look on this AI platform. So this is called AI Core, and it includes also the Generative AI Hub, which on top of the AI Core platform, where you can both train and serve your own models. On top of this AI Core platform, we also have the Generative AI Hub, which hosts all the large language models from different vendors. And so if a customer, if a tenant is using this platform, they can both train their own networks and serve their own networks, or reuse all the large language models that are deployed in a managed service by SAP. So this is just a UI where you can try to run your own prompts against the large language models. And the nice thing here is, and I think this is also a unique identifier, because you cannot have all large language models from different vendors in one place. But this is possible in SAP's Generative AI Hub, which provides a unified access, even from the coding perspective, similar to the LangChain library. You can access all the LLMs from different vendors which have different APIs in a unified way. So you can do your data science code and just switch models easily. That's the advantage of this unified access to the models. Okay, so far we have seen the platform where we can access large language models, but now we come to the point where we have our fine-tuned models. And the fine-tuned model is very specific to one customer, to one tenant. And you don't want that different tenants, which run in this cost-efficient manner in one deployment, to be able to access your fine-tuned weights and maybe learn something from it, or do it in a malicious way to exploit it. We want a tenant isolation. So if a tenant one is sending a request, it should only access the blue weights, and there should be no way to, even by accident or by hacking, to access the red weights. And the same is true for the other tenants. They should only, in an isolated manner, be able to use their own fine-tuned models. From the user perspective, it is not clear that this is a combined way to serve these fine-tuned models. Rather, it feels like it is an endpoint where you can send your request and only your model is served, or your request is served by your fine-tuned domain. But technically, this is all part of the managed service which is provided by SAP. So these three aspects are very important. First of all, the tenant isolation. Then the second thing is scaling. So this means that if a lot of requests come in and they cannot be served by a single deployment, you have to clone it like it is done regularly in Kubernetes. You have to clone the service, the web service. But you still want to include all adapters and all capabilities that were there before. And especially if taking into account that new adapters might appear over time, you don't want to have downtimes or lags while adding new adapters. So if in future you as a customer add a new task or new customers will add their own tasks, you still want to be able to have a seamless experience, and the service and response times are the same. So all these aspects, which are technically very demanding and complex, they are planned to be available in the AI platform of SAP, and this is coming in 2025. So thank you very much for attending these presentations, and we can take some questions now.
Yeah, and I was just posting in the chat asking if anybody had any questions. At this current time, there are no questions in the chat. So if you're watching this live and you have additional questions based upon what we've seen here today, feel free to type those into the chat, relay them to the speaker, and he can answer them live. Maybe just while we wait, a little housekeeping about Devtoberfest. Today is the Thursday of the last week of Devtoberfest, and we still have, I believe, at least two more sessions later today in our uh, machine learning, AI, and data day. Tomorrow is front end. We've got some excellent sessions lined up for you tomorrow on UI topics, as well as tomorrow is Fun Friday activity Spooktoberfest. So if you've got some Halloween decorations out or got your Halloween costume ready, or you just want to post a picture of any scary code that you've ran across in throughout your work life, that's a bonus activity that you can do tomorrow for a few extra points if you're trying to wrap up and get a few points to make it to Nerdvana. Because the contest also ends Sunday night at midnight U.S. Pacific time. So you still have this weekend to complete any tutorials to get additional points. We do have a question in the chat now. Caesar says, first, thank you for the presentation. But then ask, this fine tuning can work with object detection models?
I would say no, because an object detection model is a deep learning vision model. And what we see with this fine tuning is our large language model, which are based on the transformer blocks. At least to my knowledge, I have not seen it to be added for object or vision models. I'm not aware of that.
Okay. We have another question here, and this might require some explanation of what Joule exactly is. But the question is there fine tuning applicable to Joule model as well?
Dual in the like two.
No, Joule, as in the SAP assistant.
Joule. Oh, I see. Um, I would rephrase the question. I think there can be Joule applications which can make use of the can make use of fine-tuning. So Joule is an overarching terms for a lot of AI applications. And we also talk about AI infusion into products. So I think Joule is a very good product features which can be added to a lot of classic SAP products. And it is up on the product responsible to include AI into their product. So right now, Joule is not leveraging fine-tuning, but I can very much imagine that also this will be more and more available in the future.
Okay. That's currently all the questions that we have in the chat.
Great, but thank
So,
you for the questions. They were very advanced questions.
so if there are no further questions from the audience, I suppose we'll go ahead and wrap up today's session. We got some thank yous in the chat as well. Thank you for answering the questions as well as a good session. But with that, I also want to thank you for taking your time to share your knowledge with us and with the community today. And thanks everybody for attending. We look forward to seeing you and the rest of the AI related sessions that we have coming to you later today. And enjoy the rest of your Devtoberfest. Thanks, everybody.
Thank you. Bye.